Hello everyone, welcome to another video. Last week I talked about the AKS Flux GitOps extension and I had a lot of very negative things to say. I wasn't happy about the extension and maybe I was even too negative. But today I want to show you the AKS GitOps ArgoCD extension, which is the second big open source provider for GitOps, and I had an amazing time preparing for this video. Actually, ArgoCD was so great that I have already planned 5 videos in total about this topic. For today, I want to show you the basics, how to install the extension, how to get the ArgoCD UI working so you can connect. Then we're going to deploy a couple demo applications. And next week, I'm going to show you how to install ArgoCD via Helm chart. Then we also take a look how to install Helm charts themselves. And in the following weeks, we're going to take a look how to access private repositories and also how to configure single sign-on with Azure. Before I get started, let's take a quick look at what GitOps is. GitOps has been approached how to manage your Kubernetes applications that has gotten more and more popular over the last couple of years. And I also think it's amazing. The idea behind GitOps is that you have a single source of truth, that's a Git repository. Then you have an operator running inside your Kubernetes cluster, and this operator monitors the Git repository, and if there are any changes, this means new commits, then the GitOps operator downloads the new files and applies them in your cluster. This has many advantages. One advantage is drift detection. This means if the configuration inside your cluster changes, then the GitOps operator will see that the current configuration is different than the configuration in the Git repository and will remediate this. And the second big advantage is that you can lock down your Kubernetes cluster. Since you don't push any changes, you can have a firewall blocking incoming connections to the API, and automated deployments still work because the agent, the GitOps agent, connects from within the cluster or your network to Git. This means it's an outbound connection and it won't be blocked by the firewall. With that said, let's switch over to the terminal and let's get started deploying ArgoCD. Here in the terminal, we have first take a couple steps to prepare our environment so we can install the ArgoCD GitOps extension. First, I've already installed the Azure CLI and I have to install 2 extensions for the Azure CLI. So that's the K8s configuration extension. As you can see, I've already installed it. And then the K8s extension. I also already have installed this. If you also have installed it, then you can execute the same command, but instead of add, you do an update, and then you check if you already have the newest version. If not, it will install the newest version. Next up, we have to register free service provider. That's something you only have to do one time in your subscription. So we use the AC provider register namespace command, and then we provide the name of the service provider we want to register, in this case, Microsoft Kubernetes. This runs in the background, and if you have not registered it yet, it might take up to 10 minutes. I'm going to show you in a second how to check if it's registered or not, but let's register the remaining 2. So the second one is the Microsoft.container service. And the third one is the Microsoft.Kubernetes configuration. And to check, we can use a very similar command. We can use the AC provider show command, and then with the -n or also -- namespace parameter, we provide the name we want to check. And with the -o, that stands for output, we can configure to output it as a table, which is easier to read. Here it's a bit hard to read, but we can see here a registration state, and this one is registered. If you haven't registered it yet, it might say not registered, and if you have executed the register command before, then it might still registering. So you just have to wait until it says registered. And you can execute this for all three service providers. As always, all the code I'm showing you today will be on my GitHub, and the link will be in the description, so you don't have to type anything. If you want to follow, you can just copy it from the file. With this, we have configured our environment, and now we can get started. The first step is we're going to define three variables. So we're going to define the name for our resource group, our location, and the name for our AKS cluster. Then we're going to deploy a resource group with the name we just configured and the location. Then we're going to deploy our AKS cluster. And here you can see it's the most basic configuration. So you just provide a name and a resource group. And deploying or creating this cluster will take between 5 and 10 minutes. And once it's finished, I will come back and we'll continue. The cluster has been created. Now we can download the config using the AKS get credentials command. That's everything we have to do to set up our AKS cluster. Now we can install the ArgoCD GitOps extension. So let me copy the command and then we're going to take a look at the parameter. So we're using the AKS extension create command. Then as always, we provide the resource group and name of our AKS cluster. Then the cluster type is managed clusters because I'm using an AKS cluster. If you're using an Azure Arc enabled cluster, for example, K3s with Azure Arc installed, then this would be connected clusters. Next, I'm going to provide the namespace where I want to install ArgoCD. So I also selected ArgoCD because it's easy to remember. The extension type is Microsoft.ArgoCD. Here you can configure whatever you want. For auto upgrade, I configured false because I want to do the updates. The release train is preview because the extension is still in preview. And I'm using the newest version at the time of the recording. So that's 0.0. And the last two parameters are some configuration. So the first one is I configure that I don't want to use high availability. And I just see it says here height availability. This is something you can use if you have at least 3 nodes. So in this case, the extension would install the components of ArgoCD and run them with 2 or 3 replicas. And if one fails, you still have them available. The last parameter is the namespace install. Here you can configure what permissions your ArgoCD operator has. So it can be either within one namespace or over the entire cluster. And with this namespace install parameter set to false, I give ArgoCD permission on the entire cluster. Optionally, you could also provide a list of namespaces where you want to enable ArgoCD in. For example, ArgoCD is allowed to deploy to namespace 1, 2, and 3, but not namespace 4 and 5. But I think to get started, that's already complicated enough. So let's leave it with this. I'm going to execute the command, and installing ArgoCD with the extension takes around 15 minutes. So it's quite long. And once it's finished, I will come back and then we're going to take a look how we can connect with the ArgoCD UI and deploy our applications. While the deployment is running, I just remembered I forgot to mention something. And as you can see, this extension is still in preview. This means it's still quite rough around the edges. In my opinion, it already works way better than the Flux extension. But you can see it, for example, if you take a look at the extension, there's still quite some problems, mistakes. And in this week alone, I already made 2 pull requests. And after this video, I'm going to make a 3rd one. It's a bit of a hassle when you want to try something out. But I also have to say that the Microsoft team has been amazing and all the pull requests have been approved within 1 business day. So they are really behind it and trying to improve it. With this said, now let's wait until the deployment is finished and then we're going to continue. The ArgoCD extension has been installed and now the interesting part can start. Let's clean up the terminal. And before we can connect to the UI, we have to do 2 steps. the first step is we have to figure out what the admin password is. So there are two ways depending if you're using Linux or Windows. If you're using Linux, it's a bit easier. You can use this command, the kubectl get secret, then you can get the password, and in the end you can decode it base 64. Very simple. If you're using Windows like I do, it's two steps. So first we have to get the password text, also with kubectl get secret. And once we have this, then we can decode it from base 64. And this will give us the admin password. So we are going to copy this on to the side because we're going to need it in 1 minute. And the last thing is we have to enable port forwarding so we can connect to the service that allows us to access the ArgoCD UI or the server. So if you take a look at the namespaces we have currently, if you remember, I've installed the extension in this ArgoCD namespace. So if you get everything that's inside this namespace with kubectl get all and the namespace ArgoCD, then you can see there's a whole bunch of applications running inside this namespace. And it's, or at least to me, in the beginning, it was very confusing what all of this is doing. But once you use ArgoCD, you get a hang of what it's doing, and also the names are a bit telling. So for example, we have here the ArgoCD repo server. Like this application takes care of the repositories. For example, the syncing, I would guess, and the connection. Then this one, the ArgoCD server, that's the server. So we are going to connect to this service to enable the UI. And also what I haven't mentioned yet is there's also a ArgoCD CLI. So if you prefer using the CLI, you would also connect to the ArgoCD server. Then we have here a matrix, high availability proxy. And what we're going to do, since we have here a cluster IP of the ArgoCD server, this means we don't have a public IP address. We can either change this to load balancer, and then we get a public IP address from Azure, or we can just do a port forwarding and connect it via localhost. For now, we're going to do the port forward because it's the safer option since only I have access to it. But in a further video, we're going to convert it to a load balancer and then we're going to enable single sign-on. But for now, let's clean this up and configure the port forwarding. So we just use kubectl port forward and we use the port 8080. So now we can access our ArgoCD UI via localhost 8080. So let's switch over to the browser and let's see how the UI looks like. When you open localhost 8080, you will get this warning because we're trying to access an HTTPS connection via HTTP and we don't have a valid certificate. So for now, we just proceed. In your production environment, you probably have an Ingress server or another service that takes care of this. You have a certificate, maybe you have private IPs, but for now, we just ignore this. Then to log in, the username is admin. Zoom in a little bit. And the password is the one we copied from before. So I'm going to paste this in and sign in. And that's it already. So we are here in the ArgoCD UI. And the only way to tell that we're using the AKS extension is here, this version. It seems like there's something wrong because it's all version 99.99. Currently, the most up-to-date ArgoCD version is 3.0.6. But as I said, the tool is in preview and there are some minor problems, but so far everything worked great. Okay, now we're connected. Now let's deploy our first application. So to do this, we click on New App. And then we have two options. Either we can fill out here this form, which is, I think, quite a good approach to get started because most of it is quite speaking and most of it is really easy to understand what it's doing. But what we're going to do now is we are going to configure it as a YAML. This also makes it easier for you. If you copy the code from the GitHub, you can just paste it there and you're good to go. So let me paste this in. And what I'm using here is a sample application from Microsoft. So we provide a name, the AKS store demo. Then we provide the GitHub URL. Then what branch we want to use, in this case the head, that's the main branch. Then the path to our customize file. I'm going to take a look at this in a couple minutes, what a customize file is, but this is just this file here. And the last one is the destination. So in this case, the namespace is ArgoCD because our ArgoCD server is running in this namespace and the server is Kubernetes.default. This means ArgoCD is running on our Kubernetes server. And this is one of the great features of ArgoCD. You can have it running on one Kubernetes cluster and can manage as many clusters as you want. So you don't even have to have ArgoCD running on them. For now, that's just good enough. Let's save this. Now we also have all the values populated from the YAML file. So we have up here the name, a project. If we go further down, we also have the source and the path to our customers file, and all the way down we also have all the parameter from the customers file, so we could override them. So for example, if I want to change the namespace, I could just write here my namespace and would deploy the application in my own namespace, and I can see also all the images I'm going to deploy, and if I wanted to, I could change here the version as well. For now, let's just leave it the default way, and we're going to create. Now the ArgoCD operator syncs to the GitHub repository, downloads the latest commit, and applies all the files it found there. So if you take a look and click on this project, there you can see it's already creating a namespace called pets. Then we have a couple services for Makeline service, MongoDB, order service, and so on. And on the right, we have here a deployment, then a replication controller, and the pod. As you can see here on the symbol, some are already running, some are being started. And all of this is done with the one configuration we pasted in. So a couple seconds more, then we should have our application deployed. We didn't have to create a pipeline. We didn't have to set up any complicated configuration. All we had to do was provide the path to our GitHub repository, then a customers file that again, we're going to take a look in a couple minutes, and that's it. So now we deployed our application. On the left side here, we can see everything is synced, everything is healthy. 2 resources are still progressing, but nothing is missing or degraded down there. So I already have a good overview of what's going on in my cluster. So that's great, but now let's deploy our own application so we can play around with it a bit and figure out how all of this works. So let's go back to the application and delete this one. Here we have 2 different options, actually 3 different options, how we want to delete our application. So we have the foreground one, the background, and the non-cascading. The foreground one marks all resources as deleted, and then once the garbage collector picks it up, it will delete one after the other. Background, that's the default Kubernetes mode of deletion, just deletes the objects immediately. And non-cascading, I have to admit, I've never used before, and I would have to look up what it does. So for now, I'm providing the name of the application so I can delete it, and I select foreground because we can see a bit more how the application is being deleted. So let's click OK and then click on our application, and we can already see the resources are being removed quite quickly, and there you can see they are marked for deletion, and once the Kubernetes garbage collector picks them up, they will also be disappearing from this overview. So if you wait 1 or 2 minutes, everything will be gone. So the demo application is deleted, and now let's create our own application. So again, I click New App, and again, I provide my YAML file. As before, we have the destination as the ArgoCD namespace and our own Kubernetes cluster. Then the path is to my GitHub repository inside a specific folder, and there we have the infrastructure folder. Inside this folder is the customers file. Here we have the repository. Then the target revision is what branch I want to use. The project is the default one because I haven't created another one. In the next video, we're going to take a look at all of this parameter we have to provide. And the last two ones are really cool. That's how we want to sync our changes. So we configure that we want to sync automatically. And something changes in the Git repository, they will be applied automatically. Then the GitOps operator does a prune. This means if I delete an object from the Git repository, it will also be deleted from running inside the cluster. And the self-heal is if something goes wrong, it just takes care of itself and tries to heal the application. Let's save this and create our first application. While this is being deployed, you can see it's quite small. We just have one service, one deployment, and one pod running. So while our pod is starting, let's switch over to Visual Studio Code, and let's take a look at all the files we have there. Here in Visual Studio Code, here I have the customization file that's inside the infrastructure folder. So that's the folder we configured as the path in the deployment. And this file is of type customize. If you have watched my last video, that's the same as FluxCD is using. Also the type or the kind is customization. And here you reference all the resources you want to deploy. In this case, we're referencing one file called namespace.yaml inside the same folder. And we are referencing another folder that's one level above it and called app. We're going to take a look at this in a second. Now, if you take a look at the first file here, the namespace.yaml, it's as simple as it could be. It's of kind namespace, and it just provides the name of the namespace. This means this file creates the namespace. And then the next file is the customization file inside this app folder. Here again, it's of type customization, and it only references one file called demo-app.yaml. And this demo app YAML file contains the deployment. So here we configure how we want to deploy our application. For example, we have one replica. Then further down here, we have what image we want to use. So that's just a very basic image I've been using for my demos. We can configure the port. So that's just basic Kubernetes functionality. All the way down, we also have a service. In this case, it's of type cluster IP, and it listens on port 80. So by now, ArgoCD should have deployed our application. So let's switch back to the UI and let's see if everything is running. Here in the UI, it still says it's starting. Sometimes you just have to refresh the UI and then it's running. And as I said, everything is green. Everything works as expected. We can also click on the resources, for example, on this pod here, and we get some information. Like we have down here the manifest of the pod, but we can also see the events. For example, the image was pulled, the container was created, and we can also see the logs. As we can see here, it's just a basic .NET application. It's listening on port 80. Okay, so now everything is working, but I would like to have more than one pod running, and I would also like to access the application. So I'm going to change the service from cluster IP to load balancer. So let's switch back to the YAML configuration and let's make these changes. Here in the demo app YAML file, now we can change whatever we want. So for the replicas, I would like to have 5. Everything else looks good for now. And if I scroll all the way down, I'm going to change the type to load balancer. And this will give me a public IP address so I can access my service and my application. I'm going to save this and now I'm going to commit it. As commit message, I'm going to say updated replicas and service for YouTube. I'm going to commit this and sync it to the Git repository. And now it might take, I think, up to 3 minutes. That's the default time frame for the ArgoCD operator to pick up the commit and apply them. So let's switch back to the UI and let's see if our application is being deployed automatically. Here you can see ArgoCD just saw that it is out of sync and it automatically started the syncing. And right now we have the 5 pods being started. So 2 are already running, 3 are being started. And here you can also see that the service is also being updated right now. So it should only take a couple more seconds and then our application should be fully deployed without us having to touch the cluster at all. As you can see, the pods just finished. So on the right side here, we have 5 pods running and the service now is also finished. If we click on the service, we can see it's of type load balancer. And here we can see our public IP address, which we got assigned from Azure because we're using an AKS cluster. So this worked. We applied our new changes. Everything is great. But then we realized something went wrong. For example, maybe I didn't want to use a load balancer. It was just a mistake. So I have to roll back. And obviously we could go to Git, make another commit and just wait for ArgoCD to apply the new commit. But we can also click here on the top on history and rollback. And there you can see all the versions we have deployed, or to be more precise, ArgoCD has deployed for us. We can see here the information, what commit it was, when it was done, and so on. And we can click on these 3 dots and click on rollback. Then it's disabling the autosync because it's rolling back to an older version. So that's okay for now. Now ArgoCD again sees what's running inside the cluster is not what's configured in the Git repository for the commit I want to roll back to. And it already removed 4 of the pods. And our service also should be of type cluster IP now, exactly. And we don't have a public IP address here. So we could very quickly roll back our faulty version. Now the developers have enough time to apply the changes, commit them, and then push them. And once they're pushed, then I can re-enable the auto-syncing. Since we're also not running on the most up-to-date commit of our repository, we have this out of sync message. But that's exactly what we want right now. But now let's say our developers fixed the problem, pushed it to Git. Now we can re-enable the autosync. So we can click on details, click here on the right on edit. Then we can scroll down almost all the way down. And then we have here enable autosync. Then we say, yes, we want to enable it. And we also enable the prune resources and the self-heal. So that's exactly what we have enabled before. Then we save it. And here we can see we already have our 5 pods running. And the service also should be updated exactly. So type load balancer and the IP address also has changed. This brings us to the end of this video. Today we deployed a new AKS cluster. We installed the AKS ArgoCD extension and then we enabled the ArgoCD UI, deployed the Microsoft demo application, our own application, and played around with it. So we have seen once we make a commit, then the commit will be picked up by the ArgoCD operator and will be applied automatically. We didn't have to touch the cluster. But we also took a look at how to roll back to a previous version in case something goes wrong. It's just a couple button clicks and we have a working version again. ArgoCD is a very powerful tool and we are not even scratching the surface right now. So I plan to make 4 more videos where we go a bit more into the functionality, but I think this should be enough for you to get started, especially how to install it and how to access the ArgoCD UI. And there you can just click around. The UI is really good in explaining what's going on, and I had a lot of fun trying out how it works, applying my applications and changing them. If you like this kind of video, or if you have any questions, leave a comment, and I hope to see you next week for more ArgoCD videos on AKS.